Good day, my name is Aisha and I will present manufacturing changeover time reduction for dry etching tools in wafer fabrication industry using single minute exchange of dies. So this is the five agenda for today, which is first one is introduction, problem statement, methodology, result, and discussion, and last one is a conclusion. So for the introduction is Toyota Production System, or as known as TPS, is a manufacturing system developed by a supplier Toyota, and it uses Kanban to produce requirements just in time for each step of the production process. This TPS aims to eliminate waste and achieve the best efficiency rate in production, and single minute exchange of die, or stand for SMED, is a tool of the TPS and focus to systematically reduce machine changeover time and aim for quick setup. By effectively implementation of SMED, it able to reduce manufacturing operational costs and promote flexibility with the process. We move to the problem statement in this paper. The first one is manufacturing changeover time reduction for dry etching tools in wafer fabrication industry using single minute exchange of dies. Second is causes high changeover time in the production, especially to the high priority product with actual average changeover time 6.78 hours compared to the target cycle time 3 hours, which is 126% below the target. The third one is need to identify and reduce the setup within the changeover time, thus improve the flexibility and productivity in the limited resources. The objective of this paper is to develop the changeover time reduction proposal based on the SMED with lean modification in wafer fabrication process. Second one is to implement and validate the proposed SMED approach in changeover flow for etching tool in the wafer fabrication process. So this methodology is started. We have a define problem statement, objective, and scope of study. And the second one is to perform an indicator historical data. So from this data, we take a real-time observation data collection. So initial data collection and its evaluation are fundamental planning to implement SMED. Etching tool was selected as a subject for each study model based on their changeover frequency, and there's a three type of etching: type A, type B, and type C. So the second SMED improvement proposal development, and we move to implementation and validation of SMED, and last one is standardize and implementation of SMED. So this SMED, the overview of research methodology and the flowchart to develop of SMED framework is based on, we have a three-phase to develop of SMED framework. The first one, identify the exact state model definition and process. So we move to phase one is separation of internal and external activity. Second phase is conversion of internal to internal activity. And third phase is streamline and validate external and internal activities. And last one, we implementation. So the phase one is a separation of the internal and external activities. At the beginning of the process, no clear separation is stated between activities, and engagement of team needed to detail the characterization between every state model activities. And this study shows the external and internal activities and value or non-value added activities in table below. The second phase is a conversion of internal activities into external activities. The study focused on the directional internal activities to external activities after classification had been done. Conversion from internal to external setup time will offset the deviation in the external activities through the number of effective optimization. Implementation will improve total internal setup time from 10% to 30%. This phase can be executed through modify the equipment and assemble the material or manpower ahead to the next working condition. 4 states had been converted to external activities. The last phase, phase 3, streamline and validate external and internal activities. This phase will be attempt to improve through the external and internal setup. Improving external setup including activities that support workers to perform setup tasks in organized way, while improving internal setup through execution planning more than one setup at a time and bypass manual setting activities. All criteria are set up should be streamlined by working parallel, faster execution, and elimination or reduction of trial run adjustment to improve the changeover. Figure below show an example of SMED approach streamline which will be divided into two stages to be implemented on the tool, which first stage start from June 2020 to December 2020, while second stage will be end to June 2021. So for the implementation stage, pivot test of SMED framework has been carried out to validate internal activities order, which can perform better or shorter time while keep monitoring on the external activities. Data after SMED framework implementation tablet using equation below and recorded in the table. So this is the formula they're using in this paper. C of V time is a 24 hours minus 24 hours times availability and utilization. So the percentage of availability improvement and utilization improvement, and last one you can get the percentage of COV improvement. So we move to the result and discussion. So SMED approach COV time reduction progress and develop presented in two stages. The result based on the four main performance indicators, which are availability, utilization, COV time, and output. Timeline streamline illustrate in June 2020 before SMED approach. June 2020 to December 2020 is for stage 1 and December 2020 to June 2021 is for stage 2. So this is the streamline for type A. So as we can see, the figure 1.1 is a streamline before SMED approach type A, and figure 1.2 streamline is a stage 1, and last one is a streamline is a stage 2 in figure 1.3. For the result in streamline type B, for figure 2.1 is a before SMED approach, and figure 2.2 is streamline in the stage 1, and last figure 2.3 is a streamline at stage 1. So this is the result and discussion for type A. In the first stage of COV time, managed to reduce 38% from 5.81 hours to 3.6 hours with 13% of output improvement. In the second stage, able to reduce 7% of COV time while increase 2% of output. The tool utilization had achieved 97% with a better WIP profile. Since December 2020 to fill up the tool daily requirement of 0.9 K compared to 87.85% with inconsistent WIP in June 2020 as shown in figure below. Type B has the lowest availability with an average 79.23% and output with average 78.62% compared to others. First stage shows COV time curtailed by 33% from 9.32 hours to 6.20 hours, while output was able to intensive by 47%. In the second stage, the COV time was trimmed to 4.95 hours in 20% reduction, while output increased by 59%. Availability performed up to 84.33% and significant utilization up to 90.73% with the sufficient WIP available. And last one is a result for type C. COV time reduction from 5.23 hours to 4.18 hours with 20% of improvement, while output enhanced 38% from 287 wafer to 396 wafer in the first stage. COV time further developed with 52% and 21% of output increment after reduce and divert engineering activity to type B by improving the availability and utilization. So that's why this is the result and discussion for Performance indicator table based on tool and model are presented before and after SMED approach improvement. The results show the improvement in COV time for the type A, B, and C with 42%, 47%, and 62% respectively after completed two stages of the SMED approach in a year. The output performance also showing significant improvement with 50%, 135% and 67% respectively, as the results show inversely proportional to the reduction of the COV time through the SMED approach with multiple improvement on the production planning. Last one is a conclusion. So utilization of SMED system help to reduce dry etching tools change over time in the wafer fabrication industry through optimization of process changeover planning to 62% while process to improve the tool availability to 6.6% and utilized to 12%. It also able to promote flexibility within a process and focusing more to value-added job within an organization. So when through the SMED analysis, this study able to highlight the roots and characteristics of each element in the changeover state to be investigated and develop standardized framework to reduce the production planning workload. That's all. Thank you.